Hi everyone, today we are going to learn how to multiply and divide rational expressions. But before we do that, I would like you guys to practice actually multiplying and dividing regular fractions just to refresh your brain on how to actually do that process. So I would like you to please simplify the following expressions. The first one is going to be 1/4 times 8/11, and the second one is 2/3 divided by 8/15. Now, just like for the last video and for the last lesson, I had you guys use prime factorization. I would like you guys to try prime factorization again to simplify these expressions. So go ahead and pause the video and simplify these two expressions. All right, let's go ahead and check your answer. So I can't factor 1 any further, so I'm going to make that 1/4, which is 2 times 2. This is times 8, which I know that is 2 times 2 times 2. This is all over 11, which is 11 times 1. So anything that is the same on the top and the bottom, I'm going to eliminate. I have a 2 on the top and the 2 in the bottom, so top and the bottom, they cancel out. 2 in the top and the bottom, they cancel out. And I am left with 1 times 2, which is 2, divided by 11 times 1, which is 11. So our answer is 2/11. Now you might have approached this problem in a different way by multiplying straight across and getting 8/44. That is perfectly fine. You are more than welcome to do that, and it's not incorrect at all. But like I said, my goal is to try to have you guys work with prime factorization. For number 2, whenever you are dividing fractions, you can't really do it. So what we do instead is we multiply by the reciprocal. So that's going to be 2/3 times 15/8. Now I'm going to prime factor, and that's going to be equal to 2/3 times, this is going to be 3 times 5, excuse me, all over 8, which is 2 times 2 times 2. And anything that is the same on the top and the bottom will be eliminated. So the 3's will be eliminated and the 2's will be eliminated. And I am left with a 5 on the numerator and a 4 in the denominator. 2 times 2 is 4. This only works if you are multiplying your fractions. The next lesson will deal with adding and subtracting fractions, but this lesson right now deals with multiplying and dividing fractions. So you can combine both fractions to make it one larger fraction by making this 30/24, then prime factoring. That's not a problem either. That is absolutely correct. It's just this is the approach that I'm trying to get you guys to go with. So just like I alluded to, rational expressions can be multiplied and they can be divided, just like working with regular numbers. So the rule for multiplying rational expressions is the same rule for multiplying numerical fractions. Whenever you multiply the fractions together, you multiply the numerators and you multiply the denominators. And then you write a new fraction in its simplified form. So this is what I would like you guys to do. For all of these problems, the first thing I want you to do is make sure that you factor your problem first. That is absolutely crucial. It'll tell you what your factors are in the numerator and the denominator. Next, for time purposes, you can start canceling right away. So you can divide out or cancel out your common factors. You can even use your exponents rules as well, meaning if you have an x squared over an x to the third, you can subtract your exponents. So you can even use your exponent rules if needed. And then step 3, I want you to multiply your numerators with your numerators and your denominator with your denominators. So multiply the numerator and the denominators. So this property goes like this. If you have A over B times C over D multiplying straight across, our answer is AC over BD. If AC over BD can be simplified, please make sure that you do so. So for this example, we have 5x squared over 2xy squared times 6x y to the third power all over 10y. So what I'm going to do first is I'm going to prime factor. This is 5 times, and you can break it apart into x times x if you would like. So this is 5x times x all over 2xy times y times 6, which is 3 times 2, x, and then that's y times y, all over 10y. And anything that is the same in the numerator as well as the denominator will be eliminated. Whoops, I forgot to break apart the 10. The 10 is supposed to be 2 times 5. So I have a 5 in the top and a 5 in the bottom, and I have an x in the top and an x in the bottom, so that'll be eliminated. I don't have any other x's in the denominator. I don't have any 3's in the denominator, but I do have a 2 in the denominator. That can get canceled out. And it looks like I have 3 y's on top and 3 y's on the bottom, so those will all get eliminated. So what's left over? I have an x, a 3, and another x. So that's going to be 3x squared. And in my denominator, I have a 2. So my answer is 3x squared all over 2. So please note that your simplified answers are written in completely factored form. So that is the form that I would like you to write it in. So whether it's working with parentheses or if you just simply have an expression over another expression, that is perfectly fine, but preferred answers are in factored form. So let's go ahead and look at example number 8. So this says recall the sum of 2 cubes. So that means that we're going to be using that problem or using this concept in the following 3 problems. So the first thing we want to do is we're going to try to factor, if we can, to x squared minus 2x plus 4. So I have x minus 4 all over x cubed plus 8. So I'm going to write this as x minus 4 all over x cubed plus 8. That is a SOP situation. That is a sum or difference of cubes, and I call it SOPs. So I'm going to break that apart into a binomial times a trinomial. And in my binomial, I'll have an x plus 2. And in my trinomial, it'll be x squared, the opposite of plus, which is minus, product 2 times x is 2x, and then squared. 2 squared is 4, so plus 4, times, look at this parenthesis, it is x squared minus 2x plus 4. So I'm just going to write that as x squared minus 2x plus 4. And then I'm going to make this over 1 because I'm going to multiply my fraction straight across. Notice that the x squared minus 2x plus 4 is in both the numerator and the denominator. So both of those expressions will be eliminated. And I'm left with x minus 4 in the numerator all over x plus 2 in the denominator. You do not need to write those with parentheses around them because they are the only 2 expressions. If you do use parentheses, that's fine, but it's really not necessary. All right, let's go ahead and look at example number 9. So I'm going to factor each part, each numerator and denominator. If you want to make each numerator and denominator over use one fraction bar, you're more than welcome to, but you don't have to. And so what we have here is 3x squared minus 3x. And both of these terms have in common a 3x. The leftovers is an x minus 1. All over, I'm going to break apart the x squared plus 4x minus 5. I'm going to break that apart into 2 parentheses. Splitting apart the x squared into an x and an x, and asking myself, what two numbers multiply together to equal -5, but together add to equal 4? And that is a +5 and a -1. This is times. X squared plus x minus 20, I'm going to break that down into 2 parentheses. This is all over 3x. So x squared, I'm going to split that apart into an x and an x. And I'm going to ask myself what two numbers when multiplied together equal -20, but together add to equal a +1. And that's going to be a +5 and a -4. So now I'm going to identify anything that is in common or anything that is in the numerator as well as the denominator. And I see that we have a 3x in the numerator and a 3x in the denominator, so that whole piece is going to eliminate. I have an x minus 1 over an x minus 1, so that's going to eliminate. I have an x plus 5 over an x plus 5, that's going to eliminate. And I am left with just an x minus 4. And that is my answer. Just an x minus 4. Nothing is left in the denominator. This is simply my answer. All right, let's go ahead and look at example number 10. For example number 10, I have a 20x minus 5x squared, and I would recommend strongly that you rewrite this as -5x squared plus 20x. We always want our leading term to be positive, so when I factor, I'm going to factor out a negative, and this will make our leading term now be positive. So I'm going to factor out a -5x, and my leftovers is going to be an x minus 4. This is all over. X squared and x, they both have in common an x, and my leftovers is going to be an x minus 1 times x squared plus 3x minus 4. I'm going to break that apart into 2 parentheses. I'm going to split apart the x squared into an x and an x, and I'm going to break apart the minus 4 into, I'm going to ask myself what two numbers when multiply together equal -4, but together add to equal 3, and that's going to be a +4 and a -1. And then x squared minus 16, this is a dots. So I'm going to break that apart into x plus 4 and x minus 4. Now anything that is the same in the top as well as the bottom will be eliminated. So I have an x over an x, that'll be eliminated, and x minus 4 and an x minus 4 will be eliminated, and x plus 4 and an x plus 4 will be eliminated, and x minus 1 and an x minus 1 will be eliminated, and all I'm left with is -5. That is my answer. Let's go ahead and flip the page and talk about how to divide rational expressions. Well, just like with numerical expressions, in order for you to divide both sides, or divide fractions together, you need to multiply by the reciprocal of the second fraction, and everything is going to be exactly the same. So in order to divide one rational expression by another, you must multiply the first rational expression by the reciprocal of the second rational expression. So that's very fancy language for multiply. We're going to multiply the second fraction by the reciprocal. That is it. So the property is that if you have a over b divided by c over d, that is equivalent to multiplying by the reciprocal of the second fraction. So if I have 2 over 5 divided by 7 over 3, that is equivalent to 2 over 5 times 3 over 7. And which we would multiply straight across and end up with our answer being 6 over 35. Please note that if this whatever that fraction, whatever your final answer is, make sure that you simplify it if possible. So now we're going to be working with expressions. We have 7 over x plus 1 divided by x plus 2 over 2x minus 3. So that means that we're going to multiply by the reciprocal of the second fraction. And when we multiply straight across, we're going to use parentheses. So please make sure that you use parentheses whenever you multiply, because our answers need to be in factored form. Here is number 11. So number 11, I'm going to rewrite this problem. so that we are multiplying by the reciprocal of the second fraction. So I'm going to factor my numerator, and I'm going to break that apart into two parentheses, and that's going to be where I split apart the x squared into an x and an x, and I'm going to ask myself what two numbers when multiplied together equal -21, but together add to equal -4, and that's a -7 and a +3. Oh. Next, I'm going to ask myself, what do 5x and 15 have in common? So they both have in common a 5, and my leftovers is an x plus 3. Now I'm going to multiply this by my reciprocal, and my reciprocal of x is going to be x squared minus 100 all over x squared plus 3x minus 70. So that is the order in which I'm going to factor my numerator and denominator. Now my numerator in this case is a dots. X squared minus 100 can be broken apart into x plus 10 times x minus 10. This is all over. I'm going to factor x squared plus 3x minus 70 by splitting apart the x squared into an x and an x, and asking myself what two numbers when multiplied together equal -70, but together add to equal 3. Well, whenever I think of 70, I always think of 7 and 10, so I'm thinking that this is plus 10 and minus 7. So now anything that is the same in the top and the bottom, I'm going to eliminate. So I have an x minus 7 in the top, and an x minus 7 in the bottom, an x plus 3 in the top, and an x plus 3 in the bottom, an x plus 10 in the top, and an x plus 10 in the bottom, and that is it. That's all I can eliminate. So my answer is going to be an x minus 10 all over 5. That's my answer. I would like you guys to now go ahead and do example number 12 and example number 13 on your own. Go ahead and pause the video. Let's see how you do. So go ahead and pause the video, and I'm going to wait a few moments, and then I'll show you what the answers are. All right, let's go ahead and check how well you did. So I'm going to make 3x squared minus 2x be over 1. And I'm going to factor 3x squared plus 13x minus 10 into two parentheses using guess and check. I'm going to break apart the 3x squared into a 3x and an x. And I'm going to figure out what factors of 10 working with the factors of 3 can give me a 13x. Now, whenever I think of 10, I always think of 5 and 2. So I'm going to work with those numbers, and I know that 3 times 5 is 15, and 3 times 2 is 6. So I'm going to try the 3 times 15 first, or 3 times 5 first, because that's going to get me a 15. And I know that 13 is 2 away from 15, so I'm going to try that first by making putting 5 on the outside and 2 on the inside, and I'm going to check the outsiders and the insiders. 3x times 5, that is 15x, and 2 times x, that is 2x, and I want a positive 13x, so if I were to make 2 negative, 15x minus 2x would give me my 13x. So that means that I need 15 to be positive and my 2 to be negative, so that's, or my 5 to be positive and my 2 to be negative, and I believe that that's going to be my factorization. This is going to be all over 6x squared. Now, I'm going to multiply this fraction by the reciprocal, so that is 1 over 3x squared minus 2x. So this is going to be 1 over 3x squared and 2x, they both have in common an x, and the leftovers is 3x minus 2. So now I'm going to eliminate anything that is the same in the top and on the bottom. And I see that there's a 3x minus 2 in the top and a 3x minus 2 in the bottom. And there's nothing else for me to eliminate. So my answer is going to be x plus 5 all over 6x squared times x is going to be 6x cubed. So this is our answer. Let's look at number 13. Number 13, I have a SOPs situation, a difference of cubes. So I'm going to break that apart into a binomial times a trinomial. So that's going to be x minus 1. And then square, opposite product square. So that's going to be x squared plus 1 times x, which is x. And then negative 1 squared is plus 1. This is all over. I'm going to break apart the 2x squared plus x minus 3 into 2 parentheses. I know the only way to get a 2x squared is with a 2x and an x. And I'm going to figure out what factors can I get, or can I work with so that I can come up with a positive 1 in the center. So I know that when it comes to 3, we have the factors of 3 and 1. I know that 2 times 3 is 6, and that's pretty far away from the 1 that we want. So I'm going to try 2 times 1. 2 times 1 I know is 2, and 2 and 3 are only 1 away. So I'm going to put a 1 on the outside and a 3 on the inside and check. 2 times 1 is 2x. 3 times x is 3x, and I want a positive x. So that means that my 2 needs to be negative. 3 minus 2 is 1, so I think I figured it out. My 2x needs to be negative, and my 3x needs to be positive. All right. Now, I'm going to multiply by the reciprocal of my fractions. So my reciprocal is going to be 1 over x squared plus x plus 1, which is very interesting because my SOPs has an x squared plus x plus 1, so I'm not going to factor it since it's already the same in the top and the bottom, and I can already anticipate that. Not to mention this quadratic is not factorable. So if you wanted to try to factor it, you probably would have found that you can't factor it. So I'm going to eliminate anything that's the same on the top and the bottom, and I have an x minus 1 in the top and an x minus 1 in the bottom, an x squared plus x plus 1 in the top, and an x squared plus x plus 1 in the bottom. And that is it. That's all I can eliminate. So now my answer is going to be 1 over 2x plus 3. So hopefully you did pretty well on your turns, and if not, hopefully you were able to identify what your errors were and it makes sense to you. But if it doesn't make any sense to you, or you have questions over anything on this set of discussion notes, please make sure that you let me know by emailing me or talking to me the next time I see you in class. I hope you have a wonderful day, and I will see you next time.